In problem 1, we're asking the definition of variability. Variability is the spread of scores. My next choice about bias present, that has to do with sampling method. Vagueness of wording, that has to do with sampling method. Calculating the probabilities has to do with z-scores. In problem number 2, we have 3 dot plots. These dot plots are the result of taking 30 samples from the same population, because the central limit theorem says if we do 30, we'll get a good representation. It says that this arrow marks the true parameter. So this area right here is the true parameter. They want to know which has the largest bias, and we can see C is the one that is off-center. That is off-center, so it has the largest bias. In problem number 3, we're taking a recent poll shows 27% of Americans like to read the newspaper instead of reading it online. So it says 27%, so I know right away this is a proportion, not a mean. And to figure out if it's normal, I'm going to do NP and NQ got to be greater than or equal to 10. So they say assume that this is the parameter of the population. So I'm going to go ahead and calculate my NP, and I'm going to calculate my NQ, and here are the numbers I get. I get 6.75 and 18 1/8, and they want to know, is this shape normal? And the answer is not normal because NP was 6.75. On problem number 4, I notice right away it says kids take a quiz, they have a mean. So I am not doing NP, NQ to figure out if this is normal. And if I look at all my choices, I just have to assume that it's normal because it doesn't say none of these are correct. So they want to know a random sample of 40. So if I have a mean, the central limit theorem says that would be normal because it's more than 30. I want to know the probability of greater than 25 minutes. So I'm looking for the probability of x is greater than 25. So I'm going to do my observation minus my mean divided by my standard deviation over the square root of the number, which is 40. So I get 1.85. I need to draw a picture. Here's my picture. So it says greater than, so I'm looking for this area above. So then I look at my z-score of 1.85, and that's what I get. Now I look at my picture. That is not 96%. It's to the right-hand side. That's why I am subtracting it from 1. So that's how I got B. In problem number 5, we're tossing a fair coin. Probabilities of heads or tails is 50%. So right away, I know this is a proportion problem. So in a proportion problem, to figure out if it's normal, I'm going to do NP and NQ. So they want to know the probability that more than a third of the tosses are heads out of 60. So I go 60 times 1/3. That's how I get 20 tosses. So I need to figure out my mean. I am going to go, my mean is 60 times 50%, so that's 30. I need to figure out my standard deviation, NP/Q square root. So this is my standard deviation. I am looking for the probability that x is greater than 1/3. So I am going to do my observed. That's where I get my 20. Half of them are 30. Divided by my standard deviation. This is my z-score. I need to draw a picture. Here is my picture. 50% is in the middle. 1/3 is here. I'm looking for greater than. That's how I got this area. I know it's way more than 50%. So I'm going to look up my z-score. I look up my z-score, and I get that very small number. I know I have to subtract 1. So that's how I got that answer. In problem number 6, we have a histogram from data on 750 basketball games. So here's 3 points made per game. So this is not a proportion problem. We cannot do N, P, and NQ because we're not talking about proportions. We're talking about the number of 3-point shots per game. So they want to know what's the range of the sample size. So we're talking about means. So I'm going to use the central limit theorem to figure this out. So my central limit theorem says if it is a non-normal, I need at least a sample size of 30. So my choices, my smallest choice could be 30 because of central limit theorem. Then I'm going to use a 10% condition. I have 750 in the population. So 10% of 750 is 75. In problem number 7, we're talking about college teachers from a large population. So we satisfy the 10% rule. We have a normal distribution with a mean and a standard deviation given. This is about means, not proportions. I can't do NP and Q here. So we want to know what's the probability if they serve in the committee that they have average salary that exceeds $65,000. So I'm looking for P is greater than 65,000. In the problem it said it was normal. There's my mean standard deviation. We are taking a sample size of 4. So here's my z-score. I am looking for greater than. So I do my observe, 65,000 minus my mean, divided by the standard deviation of the square root of 4. I get a z-score of 2. I look up my z-score. That's what I get for a z-score. Notice that is one of the wrong answers because you must draw a picture. Here's my picture. And I could see that probability is very small over here. That's why I subtract 1 because it goes greater than. That's how I got A. In problem number 8, we have a sample size of 25. The population is normal. My mean is 60. They want us to describe the sampling distribution of X bar. Because my population is normal, my distribution must be normal. So I'm going to calculate my standard deviation. Sigma over the square root of n, I get 2. That's how I got B for the answer. In problem number 9, I'm talking about means. Because I have a mean here, I am not talking about proportions. If I'm talking about means, I could use the central limit theorem. Our population is left skewed. They want to know the distribution, the sampling distribution of mean scores. They take 36 students. So my central limit theorem says if I have at least 30, my distribution will be approximately normal. That's how I got A. Number 10, we're talking about the price of homes. It's skewed right because we have some homes that are very expensive. So I have a mean and a standard deviation. I am not using proportions. I'm using means, so I could use the central limit theorem here. It says, suppose we take a simple random sample of 100 from a very large population. They tell us very large population. So our 10% rule applies here. Our standard deviation will be calculated correctly. So I have 100. My sample distribution of X bar will be approximately normal because 100 is greater than 30. So they want to know what is the probability it is above 325,000. So that's my observation minus my mean divided by my standard deviation over the square root of 100. That is my z-score. I look up my z-score, and that's the probability I get. I need to draw a picture. Here's my picture. I put my mean in the middle. I am looking for this small amount. That probability is very small. So I'm going to go 1 minus. So that's what I got for an answer. I got a different answer than the publisher because the publisher used the calculator and I did this by hand. In the free response question is about means. So I could use the central limit theorem. My population is normal. So regardless of my sample size, my sampling distribution will be normal. So they want us to describe the sampling distribution mean for 30 advertisements. So it has the mean of 28 seconds. Here's my standard deviation because I'm going to take my standard deviation of 5 seconds, divide by the square root of 30 because that was my sample size. And this is normal because my population is normal. In part B, I am looking for the probability that the advertisements that are selected randomly will exceed the 15 minutes available. So I'm going to calculate a z-score. Probability x is greater than 30 minutes. So I am going to go 30 minus 28 over my standard deviation, which I calculated in the last problem. Here's my probability, but I need to draw a picture. I am looking for greater than, so I'm looking for this small area right here. And then once I look up that value, I need to put it in context. So there's my answer in context.